All right, today we're going to do a video lesson on 3.4, day 1, and then Thursday will be 3.4, day 2. All right, so this is just some more work on exponents and logarithms and just a few more like little tricks you can try depending on the kind of problem. So our first group of problems are exponential problems. And one trick you can do is try to get the bases to be the same. And if the bases are the same, then you can set the exponents equal to each other and then just solve. So I'm looking at problem number 1, and I'm looking at and I'm saying to myself, 49 I could have a base of 7. If I just rewrite the problem, 7 to the x equals, but now I'm going to make 49 7 squared. That way I'll have the same base of 7. But there's still up in the exponent x plus 3. Okay, so now that my bases are the same, now I can just set the exponents equal to each other. So I can set x equal to 2 times the quantity, x plus 3. And now it's just an easy algebra problem to solve. So distribute the 2 through, and then get the x alone. You can subtract 2x from both sides, and we'll get a negative x equals 6. So then x equals negative 6. As long as the bases are the same, then the exponents would have to be the same in order for them to equal one another. Same kind of problem over here. Let's try to get the bases the same. So I'm going to look at this more complicated fraction and try to say, okay, could I turn the top into a 3 somehow? Could I turn the bottom into a 4 somehow? And I know off the top of my head that 3 to the third is 27. Is 4 to the third 64? Yes. So I could write this as 3 over 4 to the third, because 3 to the third is 27, 4 to the third is 64. Now they have the same base. So now I can set the exponents equal to one another. I can set 2x equal to 3, and then just get x alone by dividing by 2. X equals 3/2. Okay, so that kind of problem we were dealing with exponents. We could have swooped them into logarithms, and that would also work. This is just something to try if you think you can easily get the bases equal to one another. These problems are all log problems, and if you can get the log all by itself, then you can swoop it into an exponent and solve it that way. So for number 1, the log is all by itself already. For swooping purposes, you might want to write natural log as log base e of x equals negative 3. So if we swoop it, it'll turn it into an exponent. E to the negative third equals x. And we never want to leave an answer with a negative exponent, so we could send this down to the bottom. Like if we put that over 1, send this down to the bottom, and when it goes down to the bottom, it'll become a positive exponent, so e to the positive third on the bottom. 1 over e to the third equals x. For number 2, you have to isolate the log first. So this log 2x needs to get isolated. I cannot divide by 2 because the 2 is in parentheses, it's part of the log. But I can divide by 4 right off the bat. I can get rid of the 4 by dividing by it. So now I'll have log of 2x equals 2. And now I need to swoop this into an exponent. Well, you always have to start at the base. There's no base written here. And when that happens, it's assumed to be a 10. So now we're going to swoop it, starting at the base. The base of the log will be the base of the exponent. So 10 to the second equals 2x. And 10 squared is 100, so 100 equals 2x. Divide by 2, that means that x equals 50. And then for the third one here, we can divide by 5. So we'll have log x equals -2. And again, when you don't see a base written there, it's really a 10. And then we're going to swoop 10 to the -2 equals x. And again, we can move that down to the bottom, so it'll be 1 over 10 to the +2, or you can write that as 1 over 100 equals x. Okay, the next kind of problems, these are all exponential problems. So now we need to isolate the exponent, swoop it into a log. This first one, the exponent's already isolated, so we're going to swoop it into a log. I know it's going to be a log, so I'm going to write the word log. The base of the exponent will be the base of the log. So log base e of 32 equals x. And all you need to do is just type this in your calculator, log base e of 32. You could type it in as natural log 32 if you wanted. And when you type that in, you get 3.466 equals x. For number 2, I need to isolate the exponent. So that means I need to get rid of this 1,000. I'm going to divide by 1,000 right away. So now I have e to the -4x equals 75 over 1,000, which I could reduce. I don't need to at the moment. I'm going to swoop it into a logarithm. So I'm going to write the word log. Log base e of that big fraction, 75 over 1,000, equals -4x. Okay, I can type this in my calculator. I could type it in as natural log of 75 divided by 1,000, and I will get -2.59027, which equals -4x. And now all I need to do is divide by -4, and I'll get the x all by itself. So when I divide by -4, I get 0.648. And that will be my answer. Number 3, I'm going to get the exponent isolated, which means I need to add 14 over to the other side. And when I add 14, I'm going to get a 34. I'm going to swoop it into a log. So log base 3 of 34 equals 2x. Type in your calculator log base 3 of 34, and you'll get 3.20983. That equals 2x. So when we divide by 2, we get 1.605. You might run into a couple of these types of problems. Really just want you to recognize that this is a quadratic, or it behaves like a quadratic. Anytime you see e to the 2x, that's the same thing as e to the x squared. So like this kind of problem reminds me of x squared minus 5x plus 6. It has the same quality, it's just that x is an e to the x. See how we have e to the x squared? So think of this x